scientists came up with a measuring system that could be universally understood. The International System of Units, also called SI units, are a globally agreed basis of measurement. There are no Chinese measuring units or French measuring units. SI units are a sort of globally understood language that expresses units of measurement. The SI base units for mass is a kilo, for length it's a meter, for time it's a second, for temperature it's a Kelvin, the amount of substance is a mole, electric current is an ampere, and for luminescent intensity is a candela. Prefixes are used to indicate decimal fractions or multiples of various units. For example, the prefix milli represents 10 to the negative third fraction of a unit, meaning that it would divide it by 1,000. So a milligram is 10 to the negative third grams, or 1 gram divided by 1,000. A millimeter is 10 to the negative third meters, which would be 1 meter divided by 1,000. These are common prefixes used in chemistry. Although non-SI units are being phased out, there are still some commonly used by scientists, such as Celsius, a gallon, and a pound. By definition, temperature is a measure of the average kinetic energy of the particles in the sample. This is similar to rubbing the palm of your hand on a carpet and moving it back and forth very fast. The palm of your hand will get warmer. With chemistry, when two particles collide, they do the same thing when one particle rubs against the other one, which is called friction. So if we had a container with a lot of these particles in it, when two of these particles would rub against each other, they would create friction, which would make it hotter. So the average of all these particles rubbing together collectively would give you a temperature. SI units are used to derive other quantities, such as pressure, speed, and force. For example, speed is defined as the ratio of distance to elapsed time. So the SI units for speed would be distance, which would be given in meters, and time, which would be given in seconds, giving us meters per second. Other derived SI units would be the Newton and the Pascal. The most commonly used metric unit for volume are the liter and the milliliter. A liter is a cube 1 decimeter long on each side. A milliliter is a cube 1 centimeter long on each side. One thing that should be recognized is 1 cubic centimeter is exactly 1 milliliter, and 1 cubic decimeter is exactly 1 liter. Density is a physical property of a substance. It's defined as the amount of mass in a unit volume of the substance. The densities in solids and liquids are commonly expressed in grams per cubic centimeter or grams per milliliter. Some of the fundamental properties that chemists measure include mass, length, time, and temperature. Derived quantities of measurement include density, velocity, and force. In SI, the base unit for length or linear measure is the meter, denoted as lowercase m. All measurements of length can be expressed in meters. For very large or very small lengths, however, it may be more convenient to use a unit of length that has a prefix. This is a table of prefixes. For the most part, chemists will stay in this area, maybe go to micro, up to kilo, where micro is 1 million times smaller than the unit it precedes, and kilo is 1,000 times larger than the unit it precedes. When a prefix milli is put in front of a unit of measurement, such as meter, because milli was 10 to the negative third, it divides the meter into 1,000. So millimeter is a meter divided 1,000 times, which would arrive at 0.001 meters. A hyphen measures about 1 millimeter. For large distances, it is most appropriate to express measurements in kilometers, denoted as km. The prefix kilo means 1,000, so 1 kilometer equals 1,000 meters. The space occupied by a sample of matter is called its volume. You calculate the volume of any cubic or rectangular solid by multiplying the length by its width by its height. The unit of volume is thus derived from the units of length. The SI unit of volume is the amount of space occupied by a cube that is 1 meter along each side. This volume is a cubic meter. A more convenient unit of volume for everyday use is a liter, a non-SI unit. A liter is the volume of a cube that is 10 centimeters along each edge. So 10 centimeters times 10 centimeters times 10 centimeters equals 1,000 cubic centimeters, or 1 liter. A smaller non-SI unit of volume is the milliliter, denoted as lowercase m and uppercase L. 1 milliliter is 1/1000th of a liter. Thus, there are 1,000 milliliters and 1 liter, because 1 liter is defined as 1,000 cubic centimeters. 1 milliliter and 1 cubic centimeter are the same volume. The units milliliter and cubic centimeter are thus used interchangeably. The relationship among common metric units of volume are shown on the table below. 1 liter is about the same as a quart of milk. A milliliter is about 20 drops of water. A cubic centimeter is about the same size as a cube of sugar. And a microliter is about the size of a crystal of salt. The mass of an object is measured in comparison to the standard mass of 1 kilogram, which is the base SI unit of mass. A kilogram was originally defined as the mass of 1 liter of water at 4 degrees Celsius. A cube of water at 4 degrees Celsius, measuring 10 centimeters on each edge, would have the volume of 1 liter and the mass of 1,000 grams, or 1 kilogram. A gram is 1/1000th of a kilogram. The mass of 1 cubic centimeter of water at 4 degrees Celsius is 1 gram. Here are some relationships of units of mass and things that we're familiar with. One textbook is about 1 kilogram. A dollar bill weighs about 1 gram. 10 grains of salt weighs about 1 milligram. And a particle of baking powder is about 1 microgram. Weight is a force that measures the pull on a given mass by gravity. Weight, a measure of force, is different from mass, which is a measure of the quantity of matter. The weight of an object can change with its location. An astronaut in orbit is weightless, but an astronaut is not massless. Temperature is a measure of how hot or cold an object is. An object's temperature determines the direction of heat transfer. When two objects of different temperatures are in contact, heat moves from one object of higher temperature to the object of lower temperature. Almost all substances expand with the increase in temperature and contract as the temperature decreases. A very important exception is water. These properties are the very basis for the common bulb thermometer. The liquid in the thermometer expands and contracts more than the volume of the glass, producing changes in the column height of the liquid.